AI just crossed a line we weren't supposed to reach this fast. A small startup from China showed something that felt impossible. A robot moving through a home with the fluidity of real human behavior. No puppeteers, no tricks. And Google are secretly building the AI brain that could run on every robot on the planet. Hey guys, Alfie here. Welcome to AI Nexus. And trust me, what I'm about to show you might be the true beginning of the robot intelligence era. Let's start with Mind-On, because what they've shown recently is turning heads everywhere. This 6-month-old Chinese startup out of Shenzhen just showcased a humanoid robot doing household chores with the fluidity that feels eerily human. We're talking about a robot vacuuming on its knees, standing up to open curtains with a gentle tug, climbing onto a stool to water plants on high shelves, carrying packages balanced on one arm, wiping kitchen counters in circular motions, picking up toys from under tables, handing over fruit baskets. The movements aren't jerky or robotic. They're smooth, purposeful, careful. And here's the crazy part. They explicitly claim the robot isn't teleoperated and nothing is sped up. No hidden puppeteer, no fast-forward tricks, no behind-the-scenes control system, just autonomous AI doing real tasks in real time. If this is legit, we're watching a massive leap in what's called loco manipulation, where robots move and manipulate objects simultaneously in unstructured environments like your actual messy home. Now here's where it gets interesting. The hardware. Instead of following the traditional approach taken by companies like Tesla or Figure, building the entire robot body and software stack from scratch, Mind-On chose a different path. Mind-On didn't build their own robot from scratch. They took the Unitree G1, a popular Chinese humanoid platform that costs around $16,000. Compare that to $100,000 competitors, and you see why developers love it. The G1 has quietly become one of the most attractive platforms for AI researchers. Affordable, rugged, packed with sensors, and flexible enough for everything from locomotion research to manipulation benchmarks. It's basically the developer favorite for experimenting with cutting-edge robot intelligence. The G1 stands about 4 feet 3, has 23 to 43 joints depending on configuration, and comes packed with 3D LiDAR, depth cameras, and force sensors. Out of the box, it's basically a blank slate. Great for kung fu demos, but needs serious software to handle real tasks. Mind-On modified it with custom grippers for those dexterous hands and plugged in their proprietary AI brain. Suddenly, this affordable platform becomes a chore master, handling tasks across diverse scenarios with claimed 80% success in unfamiliar environments. That's the industry benchmark for embodied AI that can actually generalize. But the real magic is the tech under the hood. Mind-On's whole goal is to build the AI brain, the intelligence layer that can run on any compatible robot body. Quick question for you. Do you think Mind-On's robot is truly autonomous, or is there something we're not seeing? Comment real or fake. I'm curious what you think. Mind-On's approach combines 3 powerful techniques. First, reinforcement learning, where the robot essentially practices tasks millions of times in simulation, learning from trial and error like a human learning through repetition. Every failure teaches it something, gradually optimizing its behavior. Second, imitation learning, where the AI studies human demonstrations and learns to copy those motions, building a library of useful behaviors from watching how people naturally move and manipulate objects. Third, and this is crucial, sim-to-real transfer, the bridge between virtual training and physical deployment. You can't just train in simulation and expect it to work perfectly in reality because the real world has friction, lighting variations, unexpected obstacles, and a million tiny details that simulations miss. Mind-On fine-tunes their models to handle that gap, adapting virtual learning to messy reality. The result is what we see in the demo. Whole-body task fluidity that's genuinely rare in robotics. The G1 bends under tables without losing balance, climbs onto stools without tipping, interacts with moving children without collision. All while maintaining smooth, coordinated motion. Mind-On's AI is specifically optimized for contact-rich tasks like pushing, wiping, and manipulating, solving what researchers call the data bottleneck by generating massive training datasets in simulation. Here's the crazy part, though. Mind-On is only 6 months old. They're not swimming in billions of venture capital like some competitors. Their mission is laser-focused. Create an AI brain, not another expensive hardware platform. Think of them as the android of humanoid robotics, providing the smarts that run on existing bodies. Rather than building everything from scratch, they spun out of Tencent's ecosystem, part of China's booming humanoid scene where hardware is cheap and plentiful. Their approach is modular. Sell or license the brain as a service. Imagine upgrading your basic robot with mind-on AI via an app update. That's the vision. If they nail generalization at scale, affordable platforms like the G1 become genuinely viable for homes, undercutting pricier integrated bots from Western giants. This software over hardware model could genuinely democratize robotics, making advanced capabilities accessible without the $100,000 price tag. Make sure to subscribe because every week the AI world drops something insane, and we break it down first. And MindOn isn't alone in this race to build the universal robot brain. Enter Skilled AI, the Pittsburgh startup that's making everyone's jaw drop with their so-called immortal robot controller founded by Carnegie Mellon professors. They've raised $300 million at a $1.5 billion valuation. Their skilled brain is genuinely omni-bodied, one AI model that controls radically different robot bodies. They've demonstrated a quadruped robot getting its legs literally chainsawed off, and it immediately reorganizes its gait and keeps hobbling forward. They lifted a four-legged bot onto its hind legs, and the AI just treated it like a humanoid and walked it around. Motors disabled, wheels jammed, legs tied together, limbs lengthened. The controller adapts on the fly, zero shot, no code changes mid-demo. This is online adaptation in its purest form. The same pre-trained policy changes behavior in real time when the body or environment shifts, without pausing for fine-tuning. Real talk. If a robot can lose a leg mid-task and still keep going, does that scare you or impress you? Comment scared or impressed. How is this possible? Skilled trained their AI across roughly 100,000 simulated robot bodies, exposing it to countless shapes, joint layouts, and failure scenarios. Their transformer model, Locoformer, remembers long histories of sensor data and actions. So when something changes, like losing a leg or gaining height, it infers the new dynamics and adjusts instantly. Instead of memorizing movements for one robot, it learns the general principles of balance and motion, letting it adapt to almost anything with no extra training. But wait, there's more. Google DeepMind just entered the arena with serious firepower. Google is pushing hard toward the same idea, building the AI brain first, and their newest reveal, Sima 2, is another major step in that direction. Google recently introduced Gemini Robotics 1.5, AI models that let robots reason step by step, plan tasks, use digital tools, and generalize across different robot bodies. The demos show robots sorting fruits by color, separating clothes, following city recycling rules, and even checking whether to pack bags. Two models handle this. Gemini Robotics ER, the planner that understands scenes and creates step-by-step actions, and Gemini Robotics, which converts those plans into precise movements. The key breakthrough is that these robots now think before acting, generating natural language reasoning so their decisions are understandable and far more capable. Google's Sima 2 is DeepMind's next step toward real-world robotics. An AI trained in open-world games to follow natural instructions, even vague ones, and achieve about 60% success on unseen tasks. It learns from gameplay across multiple titles using a self-improving loop, letting skills like mining or navigation transfer between worlds. Games act as infinite training grounds for embodied AI, and with tools like Genie, DeepMind can generate endless environments. These virtual skills can move to real robots through sim-to-real methods. The goal is clear: robots that follow instructions, explain their reasoning, and adapt in real homes. This is the race we're in right now. Three parallel approaches converging on the same goal: a universal AI brain for robotics. MindOn attacking from the affordable hardware plus smart software angle, skilled building indestructible, morphology-agnostic controllers through massive simulation diversity. Google leveraging their AI empire to create reasoning robots that can plan, search, and explain themselves. The winner could reshape everything, trillions in value, robots in every home and workplace, fundamental changes to how we live and work. We're talking about the ChatGPT moment for embodied AI, where robots finally learn and adapt like large language models do. China's edge in mass-produced cheap hardware combined with AI talent could accelerate this faster than anyone expected. But the US still leads in sophisticated AI architectures and reasoning systems. This isn't just about cool demos anymore. This is about who builds the Android operating system for the physical world. And based on what we're seeing in late 2025, that future is arriving way faster than anyone predicted. Remember that viral female robot XPeng revealed? The one that walked so perfectly people thought it was a human in a suit? Well, XPeng just announced that the iron platform behind it is now heading into mass production. And before you think this is a small update, even Elon Musk reacted to the iron demo, saying, "Not bad? Tesla and Chinese companies will dominate this space. Everyone else in the West is weak." If Musk is impressed, you know something big is happening. XPeng just revealed something nobody expected this early, and it changes everything. And behind this reveal, XPeng made their boldest statement yet. Mass production, from vision to reality. Just a straight-up confirmation that iron is entering the manufacturing phase. This isn't a lab experiment anymore. XPeng is gearing up to build humanoids at scale. But here's the part that really shocked everyone. XPeng didn't say whether these robots in formation were the male iron or the female iron. They keep calling it the iron platform, and they're technically right. The internals are the same, the body styling, the outer design, the appearance, those are all just skins. But let's be honest, the world isn't obsessed with the male iron, it's the female iron that broke the internet. The one that walked across the stage so naturally that millions of people refused to believe it was a robot. And if XPeng is mass-producing the iron platform, guess what that means? That smooth, eerie, almost human female version could end up being the mainstream face of iron. And that is wild to think about. But here's where the story gets even crazier. XPeng didn't just show a lineup of robots, they linked it to real numbers. They said 2026 is the year they start preparing the true manufacturing pipeline. And by the end of 2026, they expect large-scale production, not pilot batches, not test units, large-scale production. That's the kind of language companies use when they're preparing to ship thousands. And this means one thing for you and me. Humanoids aren't sci-fi anymore. They're becoming a product. If you had the chance, would you buy an iron robot in 2026? Yes or no, and why? Drop your thoughts below. I always check the comments, and some of your ideas are better than what the AI labs are doing. Now let's slow down for a second and talk about why this update is such a big deal. Because it's not only about the number of robots. It's about the female iron itself. The reason the world can't stop talking about it is simple. It doesn't move like a robot. It moves like a person. Before all this mass production talk, XPeng showed off a female version of iron at their AI Day in Guangzhou, and people were absolutely freaked out. This robot walked onto the stage with a clearly feminine shape. Slimmer waist, softer lines, model-like posture. And when it started walking, it didn't move like a typical stiff humanoid. It glided across that stage with slow, deliberate hip and shoulder movement. The arms swung naturally. It had this catwalk-style gait that made everyone's jaw drop. The audience started whispering, and social media exploded with the same question. Is this really a robot, or did XPeng just put an actual woman in a robot suit? Multiple reports say people in the crowd were convinced it had to be a human performer because the walk looked way too natural. So what did XPeng do? The CEO, He Xiaopeng, brought the robot back on stage and literally cut into it. Right there in front of everyone. He peeled back the soft white outer layer, what some articles call synthetic flesh, and exposed the internal frame. Metal rods, servos, artificial muscle structures, the whole mechanical skeleton. And get this, he actually apologized to the robot while doing it. He said he hoped this would be the last time iron needed to prove it is itself. That's both hilarious and kind of haunting at the same time. But it worked. Robotics analysts confirmed iron really does use a human-like spine and leg architecture. There's this bionic fascia layer between the frame and the skin that helps smooth out motion so it feels organic. The female walk wasn't acting or tricks. It's real mechanical engineering in the hips, knees, and ankles, giving the robot that human gait. Peng has openly said Iron will come in different body types and gender with customizable appearance and clothing. They want it to feel like a life companion or colleague, not just a cold machine. That's why they went hard on making the female version look and move so realistically. They're testing how people react to gender presentation in robots. And based on the internet response, mission accomplished. People are shocked, fascinated, and a little creeped out all at once. If you want real AI news without the fluff, make sure you're subscribed. We're just getting started. But XPeng didn't stop at appearance. They wanted to prove the body wasn't just for show. It could move. They released footage of an iron robot doing martial arts moves. And I'm not talking about jerky robotic karate chops. This thing drops into a proper martial arts stance with knees bent, feet planted wide, upper body relaxed and centered. Then it moves through this slow, controlled sequence. Arms sweeping in smooth arcs, wrists rotating into careful poses, fingers extending and curling with precision. The weight shifts from one leg to the other without any stumble or stutter. XPeng captioned it, "The Robot Kung Fu Master," with lines like, "In every move there's balance, in every pause there's power. Even robots can master the art of inner peace." Some people think it looks more like Tai Chi than hard Kung Fu because of how slow and meditative it is. But that's the point. The transitions are completely continuous, not stop-motion animation. Why does this matter? Because under the hood, Iron has 82 degrees of freedom across its entire body. That means the spine, shoulders, hips, knees, ankles, wrists, and fingers can all coordinate together instead of moving like separate chunks. Each hand alone has 22 degrees of freedom for those delicate finger movements. And it's powered by 3 Turing AI chips pushing 2,250 trillion operations per second. That's the compute power generating and controlling those motions in real time. XPeng isn't just making a robot that can walk from point A to point B, they're choreographing the whole body to move like a living thing. But XPeng didn't stop at showing off that kung fu flow. They wanted everyone to see the hardware wasn't just flexible. It could pull off movements with surgical precision, 2 female iron robots walking side by side in perfect sync. And I mean perfect. Their movements are mirrored so flawlessly it creates this optical illusion like one is reflecting the other. But plot twist, there's no mirror. Both robots are real and they're syncing up in real time. The gait is inspired by fashion models on a catwalk. It's all thanks to that biomimetic spine and muscle system that mimics human anatomy plus rapid imitation learning, where the bot copies human moves in seconds. Watching those 2 robots walk together is genuinely unsettling because of how human it looks. It highlights how repeatable and stable the robot gait can be when both units use the same motion patterns. But to understand how big this moment actually is, we need to look at what the other giant in this race is doing. At Tesla's recent shareholder meeting in 2025, they showed footage of an Optimus assembly line inside the Fremont factory, workers assembling Optimus units on a dedicated production line. Tesla AI lead Julian Ibars clarified this is a pilot research and development line right now, but a significantly larger Gen 3 production line is planned for 2026. The long-term target is absolutely bonkers. A line capable of up to 1 million Optimus units per year, with expansion plans for a Texas Giga line that could hit 10 million units annually. Elon Musk has called Optimus the most important product Tesla is working on, and he's tying it to eliminating poverty by massively increasing productivity. The economic pitch is bringing the cost per robot down to around $20,000 at scale, deploying them first inside Tesla's own factories, then out into the wider economy. Which one do you think will win the humanoid race? XPeng Iron or Tesla Optimus? I'm curious what you think about this humanoid race. So here we are. XPeng is perfecting the human side of humanoids. Tesla is perfecting the scale. Both are targeting 2026. And suddenly, the idea of seeing a humanoid robot in your home doesn't feel like sci-fi. It feels like a delivery date. The female iron robot shocked the world. Now it's entering mass production. The countdown has officially started. If you think that's wild, wait until you hear about the huge upgrades in Tesla's Optimus Gen 3. Elon Musk just dropped a bombshell at Tesla's 2025 shareholder meeting, officially revealing the new capabilities of the Optimus Gen 3. Optimus is no longer a concept. It's already walking through Tesla's offices, charging itself, and performing real human tasks with stunning precision. From folding laundry to cooking meals, Optimus Gen 3 marks a historic turning point in robotics. Optimus is evolving faster than anyone expected, and Tesla says Gen 3 will officially be showcased next year, marking a major step toward bringing a humanoid robot into your home. Musk also confirmed that production is ramping up fast, with a target price of around $20,000, roughly the cost of a small car. Here are the 5 biggest upgrades that make Optimus Gen 3 Tesla's most ambitious creation yet. Optimus robots are literally roaming through hallways autonomously, doing their thing, and when their battery gets low, they just stroll over to a charging station like it's the most natural thing in the world. No human supervision, no emergency stop buttons, just robots living their best robot life. Musk is saying that your home is about to have one of these self-sufficient humanoid machines. Not in some distant sci-fi future. Production is ramping up right now. Now, before you think this is just vaporware hype, I need to get really specific about capabilities because this is absolutely staggering. Tesla has demonstrated Optimus handling an egg without cracking the shell. Think about the precision required for that. These robots are picking up individual pieces of popcorn and serving them delicately. They're performing controlled kung fu movements that showcase balance most humans would struggle with. But here's where it gets wild. As of Q3 2025, Optimus is folding laundry with human-level dexterity. And I cannot stress enough how insanely difficult that task is from an engineering perspective. Wiping kitchen surfaces, manipulating cooking utensils with care, picking up trash and sorting it correctly, and navigating complex indoor environments completely untethered. No cables, no remote operator, just pure autonomous operation powered by real-time AI. So when we talk about cooking your dinner, folding your laundry, and taking out the trash, we're not spinning fantasy scenarios. These capabilities are documented, tested, and operational inside Tesla facilities right this second. Tesla's already running a pilot line at the Fremont factory building development units. At the 2025 shareholder meeting, Musk laid out a 3-phase roadmap that escalates so fast it'll make your head spin. Phase 1 is Line 1 in Fremont, targeting 1 million units per year. That's the starting point. 1 million humanoid robots annually from a single line. Phase 2 jumps to 10 million units per year at Giga, Texas, a 10 times capacity increase. And Phase 3? Musk joked about a 100 million per year line potentially on Mars, but then added with a straight face that they're targeting 100 million to potentially 1 billion units per year worldwide long term. If Optimus could do one thing perfectly for you every day, what would it be? Drop it below. Musk is talking about producing more Optimus robots than there are vehicles on the entire planet, and doing it in a fraction of the time. He's claiming this will be the fastest production ramp of any large, complex manufactured product ever, leveraging every ounce of Tesla's EV manufacturing expertise. We're talking about industrial scaling at a pace humanity has never attempted for something this sophisticated. Now, there's a philosophical framework underlying all of this that actually makes terrifying sense. The backdrop at the 2025 shareholder meeting literally displayed sustainable abundance. And this isn't just corporate messaging. Musk's core argument: if Optimus robots can perform the majority of physical labor cheaply and continuously, working 24/7 with precision humans physically cannot match, then the cost of goods and services collapses. He's projecting we can increase the global economy by a factor of 10 or even 100, with no obvious ceiling. Musk genuinely believes this pathway could eliminate poverty by making goods and services so inexpensive that basic needs become trivially affordable. But here's where things get properly cyberpunk and emotionally intense. The Neuralink Optimus integration opens up possibilities that sound like science fiction, but are actually on the official roadmap. Neuralink has already demonstrated their brain-computer interface, allowing a paralyzed individual to control a computer cursor purely through thought. That technology is real and working in human subjects right now. Extrapolate forward. Musk has stated explicitly that people with Neuralink brain chips will eventually achieve full body control and sensory feedback from a Tesla Optimus robot. You're not just piloting it remotely, you're inhabiting it. Feeling through its sensors, experiencing texture and temperature, moving through physical space. In more speculative thinking, Musk has floated the idea that in 20+ years, we might approximate or upload aspects of consciousness into an Optimus body, creating digital continuity for people facing terminal illness or severe physical decline. Whether that's achievable remains an open question, but the Neuralink Optimus integration for disability assistance? That's happening on the engineering timeline. Speaking of timelines, Musk literally described this as an infinite money glitch, and the economic implications are bonkers. His logic is brutally simple. Once humanoid robots can perform nearly all productive physical work, the economy is no longer constrained by human labor hours. Traditional economics treats labor as fundamentally scarce. There are only 24 hours in a day. Humans need sleep and breaks. But what happens when you have millions of robots operating 24/7, 365 with higher precision, lower error rates, and operational costs that boil down to electricity and maintenance? The constraint breaks. You're only limited by how many robots you can manufacture and how much energy you can generate. But here's the real talk about engineering challenges, because building these things is hard. Musk identified the hand and forearm as the single greatest electromechanical challenge in the entire project. He literally said this component is more difficult than the entire rest of the robot. We have 27 bones in each hand, 34 muscles controlling movement, thousands of nerve endings. Replicating that in a machine that can handle eggs without cracking them but also grip 50-pound objects? Engineering nightmare involving materials science, motor control algorithms, sensor fusion, and real-time force feedback. Musk outlined the 3 hardest problems: achieving human-level hand dexterity, developing real-world AI that handles messy, unstructured environments, and manufacturing at scale using a supply chain that basically doesn't exist yet. These aren't trivial challenges solved with one breakthrough, but Tesla is betting they can crack them through rapid iteration and manufacturing expertise from scaling EV production. Speaking of iteration, we're looking at an annual release cycle mirroring the smartphone industry. The robot at the 2025 shareholder meeting was Optimus version 2.5. Here's the roadmap. Optimus 3 enters production in 2026. Optimus 4 targets 2027. Optimus 5 slated for 2028. Each generation brings improved mechanics, better materials, more sophisticated AI. This is year-over-year compounding improvement. We went from the first iPhone to facial recognition and conversational AI in a decade. Now apply that innovation rate to humanoid robots. The Optimus in your home in 2030 will be radically more capable than today's version. Here's where everything clicks economically. At the 2025 shareholder meeting, Musk revealed a concrete cost target that changes the entire equation. Approximately $20,000 per unit at scale. Tesla's official Optimus account confirmed, "Our goal is $20,000 COGS per robot at scale." Expected retail pricing falls between $20,000 and $30,000, roughly a mid-range car or less than annual rent in major cities. For a humanoid robot that works 24/7, performs household chores, provides disability assistance, and could replace human labor in countless applications, that price point is game-changing. We're not talking luxury items for tech billionaires. We're talking robots as common as refrigerators, potentially with financing options making them accessible to average households. Would you actually buy a $20,000 Tesla robot for your home, or is this future moving too fast? Let us know in the comments. We're reading every single one. So, bottom line, Optimus robots are already operational, walking autonomously through Tesla facilities. They can cook, fold laundry, handle delicate objects with human precision. Production lines are scaling from 1 million to potentially 100 million units yearly in what's being called the fastest manufacturing ramp in industrial history. The vision is sustainable abundance, using cheap robotic labor to eliminate poverty. Neuralink integration could give people with disabilities full robotic body control. The $20,000 price target makes these affordable for average households. Long-term goal is tens of billions of units, potentially one robot per person globally. And Musk's trillion-dollar package depends entirely on hitting these targets, meaning Tesla is betting its entire future on this. Do you think robots replacing human labor will create abundance or chaos? Comment your take. I want to see where you guys stand on this. We're watching the robotic revolution unfold in real time. This isn't speculative futurism. Production has started, the technology works, and the price point is finally achievable.